Hello everyone and welcome back to Education Foundation, and in today's video we'll be looking at Maxwell Loop Analysis. So what is Maxwell Loop Analysis? Maxwell Loop Analysis is simply a method that is used for finding different sections in our circuit, like the resistance or the current, using the matrix and determinant method. So from this circuit that I have drawn, we are going to derive the formula that we are going to make use when using Maxwell loop or mesh analysis. So the formula, according to the matrix and determinant method, is R1, 1, R1, 2, and R1, 3. Then for the second row, we have R21, R23, R22, R23. Then for the third row, we have R31, R32, and then R33, all in brackets. So now on this side, we will have a value of current, which is I1, I2, and then I3, all in brackets, which is then equals to V1, V2, V3, all in brackets. So this is the formula we are going to be making use when considering the Maxwell loop stroke mesh analysis method. So let's take the note of what each parameter stands in this equation or in this formula that was given. So here, R11 is equals to the total resistance that occurs in loop 1. So that will be R1 plus R3 plus R2. R1 plus R3 plus R2. Then now for R12 is the common resistance between loop 1 and loop 2, which is R2. But in this case, we should take note that we will not just write the value of R2 like that. We are going to write the negative value, which will be equal to negative R2. Then R13 is the common resistance between loop 1 and loop 3, which is R3. So we will now write the negative resistance, as I said earlier, of R3. Here, instead of it being R2 to be R3, but both of them will be negative, since they are both mutual resistance, or since they are both mutual resistances of two loops. So now let's look at R21, which is equal to negative R2. Then R22 will then be equals to R2 plus R5 plus R4, which is equal to R2 plus R5 plus R4. We should take note that this R21 is the same thing as R12. So in other words, Our next value that we are looking for will then be arrow 2, 3, which is the common resistance between loop 2 and loop 3. So the common resistance between loop 2 and loop 3 is arrow 3, which is equal to negative arrow 5. So now let's look at the third rule, which is arrow 3 which will then be equal to negative arrow 3. As I said earlier, arrow 2 1 is the same thing as arrow 1 2. So arrow 3 1 will be the same thing as arrow 1 3. So this will be equal to negative arrow 3. So arrow 3 2 will then be equal to the same value of arrow 2 3, which is then equal to negative arrow 5. Then arrow 3 3 equals to the sum of the individual resistances in loop 3, which is arrow 6 plus arrow 7 plus arrow 5 plus arrow 3, which is equal to arrow 6 plus arrow 7 plus arrow 5 plus arrow 3. Let's put this in brackets so that we make it easy and not confuse ourselves. So this is our value or these values are simply the resistance values that we have in this circuit, or how to get the resistance value when we are making use of Maxwell's loop stroke analysis. So when we are making use of Maxwell's loop stroke mesh analysis method. Now that we know how to get the parameters of arrow 1 1 to arrow 3 3, we are now going to take an example below.